Welcome to Lesson 3 of Module 6, a notation for entity relationship diagrams. I'm going to start with a question about the difference between two data modeling concepts. What is the difference between existence dependency and identification dependency? Lesson 3 expounds on the basics of ERDs provided in Lesson 2 to some specialized but important relationship variations. These relationship variations do not occur often in practice. However, when occurring, these variations are important parts of a data model. The objectives in this lesson involve two specialized types of relationships: identification dependency and many-to-many relationships with attributes. You should be able to articulate the elements of identification dependency in an example. To demonstrate understanding of many-to-many relationships, you should be able to apply the many-to-many relationship equivalency rule to an example. The most important objective is to appreciate specialized relationships, but avoid temptation to overuse them. Typical novice mistakes in data modeling are to overuse specialized relationships. In some business situations, an entity type may not have its own primary key. Entity types without their own primary key must borrow part or all of their primary key from other entity types. Entity types that borrow part or their entire primary key are known as weak entity types. A relationship that provides a component of the primary key is known as an identifying relationship. Thus, an identification dependency involves a weak entity type and one or more identifying relationships. Identification dependency occurs because some entities are closely associated with other entities. For example, a room does not have an identity separate from its building because a room is physically contained in a building. You can reference a room only by providing its associated building identifier. In the ERD for buildings and rooms, the room entity type is identification dependent on the building entity type in the contains relationship. A solid relationship line indicates an identifying relationship. For weak entity types, the underlying attribute, if present, is part of the primary key, but not the entire primary key. Thus, the primary key of room is a combination of building ID from the building entity type and room number from the room entity type. One of the differences between an ERD and a relational database diagram is that relationships in ERD can have attributes. This situation typically occurs with many-to-many relationships. In a many-to-many relationship, attributes are associated with a combination of entity types, not just one of the entity types. If an attribute is associated with only one entity type, then it should be part of that entity type, not the relationship. In this ERD, the attribute enroll grade is associated with a combination of a student offering, not either one alone. For example, the enrolls in relationship records the fact that student with student number 123779993 has a grade of 3.5 in the offering with offer number 1256. To provide clarification about many-to-many relationships with attributes, these partial ERDs show more examples. In example A, the attribute quantity, for QTY, represents the quantity of a part supplied by a given supplier. In example B, the attribute auth order represents the order in which the author's name appears in the title of a book. To improve your understanding of many-to-many relationships, you should know an important equivalence for many-to-many relationships. An M-to-M or many-to-many relationship can be replaced by an associative entity type and two identifying one-to-many relationships. This associative entity type style is similar to the representation in a relational database diagram with an associative table containing a combined primary key consisting of two foreign keys. If you feel more comfortable with the one-to-many style, then use it. In terms of the ERD, the many-to-many and one-to-many styles have the same meaning. As an example of the many-to-many relationship equivalency rule, the enrolls in relationship is replaced by two identifying relationships, registers and grants, and an associative entity type, enrollment. The relationship name enrolls in has been changed to a noun, enrollment, to follow the convention for nouns for entity type names. There is one situation when the one-to-many style is preferred to the many-to-many style. When a many-to-many relationship must be related to other entity types and relationships, you must use the one-to-many style. Since this situation is not common, the choice of a many-to-many relationship or an associative entity type is largely a matter of preference. Now, let's wrap up Lesson 3 about relationship variations for ERDs. This lesson covered two important variations, identification dependency and many-to-many relationships with attributes. You learned about an important equivalency rule to transform many-to-many relationships with attributes into an associative entity type in two one-to-many relationships. This transformation is largely a matter of personal preference. Most students prefer the associative entity type representation because it is similar to the representation in a relational database diagram. These relationship variations are not common in practice, but important when they occur. However, typical novice mistakes are to overuse specialized relationships, so make sure that you understand them before using them in practice. For Modules 6 and 7, you should focus on understanding the notation in ERD for both kinds of specialized relationships. Modules 8 and 9 will give you practice with analyzing narrative problem statements to determine when these specialized kinds of relationships are appropriate in business situations. In answer to the opening question, identification dependency is a specialized kind of existence dependency. Recall that an existence-dependent entity type has a mandatory relationship that is a minimum cardinality 1. Weak entity types are existence-dependent on the identifying relationships. In addition to the existence dependency, a weak entity type borrows at least part of its primary key. Because of the existence dependency in the primary key borrowing, the minimum and maximum cardinalities of weak entity type are always 1. Thus, identification dependency implies existence dependency. Existence dependency is a common situation in business databases. In contrast, identification dependency is much less common, even rare in business databases.